Hello, today we are talking about DAP.live, the analytics platform provided by the DNS Research Federation, a new not-for-profit providing data services about the DNS. Thank you, and I'm pleased to introduce my two colleagues, Nathan Allen and Mark Robertshaw. And today we're going to be going through different parts of the system. Today we'll start with an introduction to the DNS Research Federation and DAP.live. And then we'll look at DAP.live in action, that is through three use cases. The first is data inputs, and we'll be using blockchain domains as an example for that. Our next project is data analysis with the internal Internet Standards Observatory. And finally, we'll be looking at data outputs with key domain name system metrics. So first of all, a quick overview of the DNS Research Federation. It's a new not-for-profit organisation based in the UK, and its mission is to advance the understanding of the domain name system's impact on cybersecurity policy and technical standards, and its areas of activity are education and research, providing access to data and engagement in technical standards. Just broadly, an overview of the DAP.live platform that we host. It's dealing with four problems. It's dealing with four problems. One is knowledge translation, and we address that by providing a number of dashboards showing different use cases for different consumers, as well as in the area of research, mentoring and support and training for researchers, teaching researchers how to research. In terms of data access, we're helping people solve different licensing challenges for different use cases. So, for example, the intended use of data matters, and that adds complexity. Regulatory things like GDPR also add to the complexity, as well as formats of data. There's JSON formats, comma-separated values, file dumps, bulk data, on-demand data. All of those have different problems that we attempt to solve. In terms of data quality, we're looking at standards, the reporting, escalation workflows, and things like the taxonomy, what we call data and what we call data objects. Finally, the data cost. We are ourselves developing unique data feeds so that people get access to new kinds of DNS data. And also, we are, as ourselves, acting as a kind of not-for-profit market with bulk purchasing and discounts for all, and I'm pleased to say we have 60 plus feeds. So first of all, I'm going to hand over to my colleague Nathan Allen, who's going to take us through the first case study looking at DAP.live inputs with blockchain domains. Love them or hate them, they're being registered in their millions and they are resolving to browsers, so it's something that we've been asked to look at. Thank you very much.
Thank you, Lucian. So, as Lucian mentioned, one of the case studies that we're going to look at is the data that we have around blockchain domains. Now, on the DAP.live platform, we have a number of different data sources. We have data ranging from traditional DNS domain names through to IP, ASN data, whois, and website data. And because we work with a lot of researchers, a lot of the data that we have is driven by the research that they're doing, and this is the case for blockchain data. We have a number of different feeds relating to blockchain domains, and that's come about because of the relationship that we have with our researchers. So the use case I'm going to go through today is going to focus on a couple of areas. What we want to do on the system is filter the set of domains that we have down to a set that is meaningful to us. And then we want to try and find out how some of these blockchain domains are actually being used. So to give you an overview of some of the data that we have available in the system, we have just over 6 million blockchain domains that have been registered. We have that across a number of different providers. And we can see that we have data ranging from 16 different TLDs. Going into the data itself, you can see that it's quite a wide data set. We have information relating to the domain, the TLD, when it was created, and when it might expire. So let's try and make sense of some of this data that we have. So as an example, what we're going to do is we're going to filter this set to make it more meaningful to us. So we're going to look for all of the blockchain domain registrations that contain the word Google. So we can do that on the system by going to the filter tab and performing our filter on the system like that. We can see that we have a number of different interesting data points relating to these domains. You can register different character sets, you can register emojis, and you can also, as you'll see at the top, register domain names that contain spaces. So that's an interesting point worth mentioning. In total, from the search that we've done, there are just over 2,000 domains that are currently registered on the blockchains that we have access to that contain the word Google. So another nice feature of the system is being able to join in other data sources throughout the system. So we filtered our records down to those that contain the word Google, and now we want to try and find any resolver records that relate to those. So we can do that by using the join data function of the system, and we'll go ahead and join in the blockchain domain records. From here, we want to tell the system that we want to match records based on the domain name. And you can also filter down the set. Because you end up with a wide set of data, you may want to only select the columns that are relevant to what you're looking at. So for example, here I've selected I'm only interested in looking at the domain, the TLD and the created and expiry date, along with the record type and the value. So here we have the data. We have our domain names to the left, and we have the records where those domain names resolve to on the right-hand side. So we may want to filter this set even more so that we can have an understanding as to how these domains are being used. So in this case, we're going to perform a filter that will result the set to those domains that are resolving to cryptocurrency wallet addresses. And we can see that of those just over 2,000 domains that contain the word Google, 1,800 of them are mapping directly to crypto wallet addresses, which is a fairly standard use case for a lot of these blockchain domain names. So the next thing that we can look at, we've seen how many are being used to be mapped to cryptocurrency wallets, which is quite common. Let's see if we can find anything else out about these domains. So in this formula, what we're going to do is we're going to ask it to find us all of the records where the record type contains the word sale. And that means that the person has actively said that this domain name is for sale. So again, filtering that down by that criteria, we can see that of those 2,000 domains, around 79 of those have been marked that they are ready for sale. Again, another use case that we can look at with the information that we have is, are any of these blockchain domains being used to publish content on the blockchain in the form of a HTML website? So again, we can quickly change our formula to look for the word HTML in the resolver record type. And again, that will reduce the set even further. And we can see there's only about 10 or so of those 2,000 where they have records that are pointing to blockchain domain websites. So as an exercise here at the DNS Research Federation, we've registered some domain names on the blockchain to get an understanding of how they work. Here's a couple that we have registered ourselves that's to do with the research project that is ongoing. And as a test case scenario, we were able to get a very simple website up and running within a matter of minutes, to be honest. And this is the website in question. And it's worth noting that the blockchain domain names don't route through the traditional DNS system. So browsers such as Safari, Chrome, and Firefox, they just simply won't work. But there are a couple of browsers that will support them. So the example that you see on the screen is the Opera browser that successfully manages to resolve some blockchain domains. And so that's an overview of what we've been able to do today. We've been able to filter a set of data results in the blockchain domains to a more manageable set. We've been able to join in any resolver records for those, and we've been able to find out how they're actually being used. So in most cases, they're being used for crypto wallet matching. In some cases, websites, and in some cases, people are looking to sell them on. So thanks for watching this part of the video.
Thank you very much. And now we're going to go over to my colleague Mark Robertshaw, and he's going to talk more about analytics.
Thank you very much. As Lucian mentioned at the beginning of this presentation, one of the applications of the DAP has been in the area of tracking internet standards. And this uses a very different feature of the system, which is the ability to index documents of different types. And actually, the system is very flexible in its support for this. We can index PDF documents, Word documents, HTML files, and quite a wide range of other text formats as well. So we're going to use that as an example to show some of the analytical techniques we can use within a DAP using some document analysis. So we start our journey, and this is our use case. We're going to ingest a few set of Word documents, which in this case, for example purposes, are actually about COVID-19. They're supplied from the government websites. They're fairly neutral documents. And we're going to look to score those documents using the built-in tools for relevance according to the prevalence of relevant keywords. And in the case of this example, we've actually taken keywords to do with higher education as our use case. Look how well these documents score for that particular theme as an example. So you can see that this is where we're going to end up at the end of the process. We've got our documents in a system with a nice presentable dashboard where we can see the documents there in that table at the bottom with a score for each document with relevance. And we can see that that score is comprised of two scores involved there, one which is to do with unique keywords and one to do with total keywords. And we've been able to rank the documents using the built-in tools within the system. So I'm going to explain to you now how we got to this final result and reverse back through the system to show you that. So to start with, we import the documents, and the DAP allows us to import documents in different ways, but the main way is to actually import them via a direct upload. And you can upload zips containing lots of documents, or you can upload single documents, whichever works best for you. And you can see they get imported in the system in a fairly straightforward way. And you can see that we've got the file name, and also the original text is pulled out for you to have a quick preview when you at the point of import, so you can confirm that you've actually got the right document and the size and things are correct. Moving on from that, as mentioned, when we import documents, we also extract all of the words from the document into an index. And you can see here that we've got all the words for the documents we've ingested here, and the number of times those words occur in each document with a frequency. And you can see also that we index not just single words, we index phrases as well. So we can actually index phrase up to a given length. In this case, we are using phrase up to length of 3. So as well as getting the word ability here, for example, we also see the phrase ability to disapply, for example. So we have triplets as well as duos, as well as single words in this example. So having done that, the next thing we'd want to do is to define a list of words that we're interested in using for matching. Set of keywords, and as we mentioned before, this is to do with higher education. So we've chosen some phrases that we would expect to see appear in a document to trigger the rules around higher education. So this list here we can ingest into the DAP, again using one of our custom data sources available, and simply insert this list of words into a custom data source for use in deriving the formulas we want. You can see as well as that, we've also defined another custom data source which allows us to encode certain rules. And in this example, we're defining how the way in which we're going to weight the unique keywords that we find. We're going to treat that as a 60-40 split between unique keywords and total keywords. So unique keywords being the number of distinct ones we find, and a total being the total number of keywords we find across all of the different ones we're looking for. And you can see that we've also set some thresholds here where we want to consider 6 unique keywords as being 100% effectively. We're not going to worry about many more than that. That's quite a lot of unique keywords for a document. So 6 is a good threshold. And likewise for the total keywords occurring in document, 15 seems like a sensible maximum there. So we've set some rules defined in the system using one of our custom data sources. So going forward from there, we can now go back to our document list, and this is just a different view of a document list. And very much like the first example, as shown by Nathan, we can query documents in the usual kind of way using the same tools, exactly the same tools as any other data set. So we've pulled our documents into our core query engine, and from there we're going to then start to join other data in. So we're going to start by joining our keywords summary in, which is joined based upon a file name matching our document file name. This is going to actually bring in our the words list into the system, so we can see all of the words. And you can see that we've now got a list of keywords against each document in the final column there, so we can see which keywords have actually been used, and also we can see the number of times each keyword has the number of total phrases that have appeared and the total frequency as columns as well. So we've now been able to join in for each document some more in metadata about the words in use for that particular example. Going forward from that, we can also join in our rules, which we're going to need to use for the scoring in a minute to actually work out some actual maths around this. So we join our scoring rules in and we get a much wider set now, which has not only the data around keywords, but also some data around the rules that we're going to use to apply to do the maths to work out. And you can see we've got a wide table now with the rules in as well on the right-hand side of that chart. So now what we do is we use the built-in formula functionality we have within DAP to derive various different scores. And here we're going to look at the unique keyword score. And you can see that the DAP provides you with an ability to write quite elaborate formulas. And these are well documented within the system as well. And you can actually look at inline documentation to look up the different sort of functions that you can use, and also the columns that you can use within your formulas, which you can see inside the square brackets in that example. So here's an example where we've created a unique keyword score using some maths. Likewise, do the same for the total keyword score using similar kind of maths, but different values we've got within our set that we started with. And finally, we work out the total score by adding the two up to get the proportion that we're using for unique and total as a sum there. So coming back out of here, you'll see that we end up with an extra columns on the end that we've defined, our formula columns, our unique keywords, our total keywords, and our total score, which have been derived using the columns before that point with the formulas as explained. So we've now got ourselves to a point where we've been able to create some scoring using the built-in tools in DAP to create a score for each document. So this brings us back to the page we saw at the very beginning, and you can see that we're now able to show those scores and indeed to sort the list of documents by the score that we've derived. And also we can show some charts above which show various different ways in which we're using those keywords and how the keywords appear in the documents as well. So hopefully that gives you a flavour for how we can use the analytical tools to work with quite an elaborate example using documents and analysing those using the built-in DAP tools. So thank you for listening.
Thank you very much, Mark and Nathan. So Nathan took us through some data inputs, that part of the DAP, using blockchain domains. Mark took us through then the analytics part of the DAP.live platform, showing you how to get intelligence out of document analysis and expressing that as charts and graphs. I'm now going to take us through the final part of DAP, which is outputs. And so looking at outputs, we're looking at a typical scenario of dashboards and widgets. Here's some dashboards. This is one that we've got on our own wall, measuring and using DAP itself as an analytics platform. We have to manage that whole service. We've got another, this is a blockchain domains, another on exploring the DAP dashboard, which we'll talk about in more detail. So on the front page of our own website at dnsrf.org, we have some widgets and a dashboard, which is showing more traditional key metrics around domain names, domain name growth, and things like that. So if we look at the first widget, we're looking at domain name growth. This is the growth that we're spotting within the domain names that we're watching within our own platform, within our own system. It's not exhaustive. There are more domains in the world out there. Some organizations are very generous with sharing data about their domain names for research and other things. Others are a bit more closed, and we always invite more people and more CC/TLDs particularly to share their data, as we have cases in the UK and Sweden who are very generous with their data and domain name analytics services. Here we can see with domain name growth, we're merging a number of feed sources together from the CZDS as well as CC/TLD zone files. This is the more traditional stuff. We also have a measure for ourselves of 100 top 100 popular domains. We're using two sources for that. We're using Tranco, which is a new academic feed measuring domain name growth, and together with the Google Crux feed and we're sort of merging those two, and it's interesting to see which domains are appearing in both and which aren't, and we have our own reasoning for that, and that's another time perhaps. But we think that that's a good resource to replace Alexa. So going back to the standard domain name growth, let's have a quick look at how we would get DNS Research Federation data into the website from DAP.live. Here we have a typical widget where it's got some data, some high-level data metrics, and a chart and graphs. If we look at the back-end software for that in HTML, we're basically, this is pre-compilation, setting some JavaScript objects. We're setting a data path to pull in data from a third-party source. In this case, that third-party source is DAP.live. So I'm just breaking down how we would typically feed any website with DAP.live data. Here we're using something that's not a standard library, it's our own library that we've developed, but it is using open source tools, and we're aiming to make more of these client-side software objects available as open source projects in the future. But for those of you that know about HTML and JavaScript, this is quite a good pattern to go by, and this is how you might typically approach it. Once we've set that data path pointing to DAP, we then will populate an object and pull out some data from that JavaScript object. Here we're getting the summary state data metric ID field, and we're also using a function with that to generate comma-separated thousands, and that's producing that total on that widget that you saw earlier. Then we look at the chart. We're using a popular chart library called Chart.js, and we're feeding that chart library with what it needs from some data coming in from our data feed. So this is the JavaScript side on the client side pulling in this data, and we're then setting some dynamic properties in the back end of a piece of website software, which gives us the feed path and the chart feed path that we need to pull all of that together. And so what we're doing is we are taking some data feeds. We dealt with inputs, which have been put together for that snapshot. They're just merging data feeds. And we're creating a stored query out of that with our analytics tools. And now we come to and that has generated the linear data that we need for our widget object. And what we then do is set up our own API connection to give us a hook into that data. And with DAP, we're able to create our own API connections, and we can call it what we like. And as we've done here, we give it a path to domain name growth 6 months, and we have some examples of some different ways of accessing that data directly through API keys. And that is the path that we're feeding into this JavaScript object. So getting quite deep and quite techie there, but that's how we complete the circle of getting domain names back into charts and graphs. And here we are, the same technology is working on our own office wall. So in conclusion, DAP.live is a data sharing platform provided by the DNS Research Federation. It's serving a variety of use cases. We have as inputs 60 plus built-in data feeds, as well as opportunities to bring your own data into that mix. We have analytical tools which give you summarization, filtering, joining, labeling, and sorting. And we also have outputs which can feed into visual dashboards, widgets through API connections. So big thank you from the three of us. Thanks to my two colleagues. If you want any more information, it's at dnsrf.org, or you can email us at support@dnsrf.org. Thanks for your time.